Hello everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम आर्टिफिशियल इंटेलिजेंस की क्लास करने वाले हैं जो कि क्लास नंबर आपका 3 है। ऑलरेडी हमने 2 क्लासेस कर लिया है जिसमें हमने यूनिट 1 कंप्लीट भी कर लिया है। दैट इज़ योर इंट्रोडक्शन टू एआई, दैट इज़ इंट्रोडक्शन टू आर्टिफिशियल इंटेलिजेंस, जिसके बारे में हमने सारी चीज़ें कर ली हैं, पार्सर, पार्सिंग एंड as well as the lexical analysis and artificial intelligence. All the things that is included in your syllabus we had done in the unit 1, and at the last of this lecture I will be telling you what we had covered up and what we have to cover up in the next coming classes. So today we'll start with the unit 2, that is your introduction to search. Introduction to search, this is the second unit of your artificial intelligence. So now we'll start with this, and starting with this, the first we have to know the searching process. In this meantime, the searching process here, they can ask you define searching process, or what are the different parameters used to evaluate the search technique, or the list the criteria that measures the performances of the different search strategies as well. In the same case, these has been asked of the 5 marks question. So you can answer one on one that the searching, for the searching one, the searching is a sequence of steps that transforms the initial state to the goal state. The process of the search include, the first is that the initial state descriptions of the problem and a set of legal operators that change the state, the final or the goal state. Like for parameters used to evaluate the search engine that we have to discuss here, that is the parameters used to evaluate a search and technique. For this, the first we have, there are the 3. The first is completeness, the second is the space and time complexity, and the third we have optimality. For this we'll discuss in the detail, and that is your completeness. In the completeness, by the completeness, the algorithm finds an answer in the some finite time. So the algorithm is said to be complete, and if it is guaranteed to find a solution if there is one. The second we have is your space and time complexity. In the case of this space and time complexity, that with the space and the time complexity we address the memory required and time factor in the terms of the operations that is carried out. The third we have is your, that is optimality. In the optimality here, that optimality tells us how good the solution is. So an algorithm of or a search process is said to be optimal, and if it is, gives the best solution here. Now with this we'll discuss the another thing, that is to describe the types of search strategies. Types of search strategies. In the same case of the types of search strategies here, where we have to discuss that in detail as well, and in the same references, there are the 2 types of search strategies. The first is your uniform search, and the second we have your, that is informed search. So uninformed and informed search, that is uninformed search. In the uninformed search, if I'm talking about, so the uninformed search means that they have no additional information about the states beyond that the provided in the problem definition, where an uninformed search should proceed in a systematic way of exploring nodes in some predetermined order, or simply by selecting the nodes at that time of a random. Uninformed search is also called the brute force search, or a blind search, or an exhaustive search as well. It is of the following type, that is a breadth first search. Just write it down here. These are of 3 types. BFS, that is your breadth first search. The DFS, that is your depth first search, and the third one is UCS, that is your uniform cost search. So these were the 3 searches that has been come under in the uninformed search. The second one we have is your, that is informed search. In the informed search, if I'm talking about, in an informed search, the algorithm contains an array of knowledge such as how far we are from the goal, the path cost, and how to reach the goal node, etc. This knowledge helps agents to explore the less to the search space and find more efficiently the goals node as well. And same case, that informed search method that often depend on the use of the heuristic information. And informed search is also known as the heuristic search as well. The types of informed search, if I'm talking about, so these were the three types, and that is, the first is your hill climbing, the second is your best first search, and the next is your apstick algorithm. These were the three types as well, and these were also the three types: breadth first search, depth first search, uniform cost search, hills climbing, best first search, and the apstick algorithm. Now we'll discuss in the detail, that is your the difference between the informed and uninformed search, and hopefully you had gone through with that जो हमने अभी किया है. From that you will be understood about the differences between, but we'll discuss because this has been asked here as well. So now we'll discuss about it. Difference between informed search and uninformed search. For the informed search and for the uninformed search here, in the informed search, that what we have to discuss is that it uses the knowledge to find the step to the solution, and for that uninformed, that is no use of the knowledge. The second is that it is highly efficient as the consumers consumes less times and cost, and uninformed is efficiency is mandatory. That is mandatory as well. For the informed cost, the cost is low, and uninformed search, that is cost is comparatively high. For the informed here, it finds the state solutions more quickly. Uninformed search, that its speed is low. For the informed search, that for example a best first search or an apstick algorithm, as I told you about. And for the uninformed search, that is the breadth first search, depth first search, and as well as your that is uniform cost search as well. Now we'll discuss about the breadth first search and a depth first search in detail. That is very important here. Breadth first search, that is your BFS. In the breadth first search here, that the breadth first search is an algorithm for traversing or searching tree. It starts the tree root or some arbitrary node of a graph, sometimes referred to as a search key, and explores all the neighbors nodes and present depth prior to moving on to the nodes at the next depth level as well. The algorithm that creates a variable called node list and set it to an initial state until a goal state is found or a node list is empty, that it will remove the first element from the node list and call it E if node list was empty quite. For each way that each rule that can match the state described in E. So they do that. The first is that they apply the rule to generate a new state. The second they do is, if the new state is a goal state, quit and return to the state. Otherwise, add a new state to end of the node list as well. Now for that, this is the next one. We have your depth first search. For the depth first search, that is your DFS. Before starting with the depth of a search, that is DFS here, we have to discuss some of the advantages and as well as the disadvantages of BFS here, that we'll discuss, and then after that we'll discuss about the DFS here, that is your depth first search. And the advantages of BFS, that is your breadth first search, the advantages is that if there is more than one solution for a given problem, then BFS provide the minimal solution which requires the least number of steps. And for the disadvantages, it has that it requires lots of memory, since each level of the tree must be saved into the memory to expand the next level, and BFS needs lots of time if the solution is far away from the root node. Now we'll discuss about the DFS, that is your depth first search here. In the same case, that for the depth first search, that it create a that a depth first search is an algorithm for traversing and searching a tree. The algorithm starts at the root node and selecting some arbitrary node as a root node in the case of the graph, and explore as far as possible along each branch before backtracking. With the same regard of it, the algorithm is that if the initial state is a goal state, quit and return success. Otherwise, do the following until such success or the failure is signaled, that is to generate a successor E of initial state, and if there are no more successor, signal failure. So with that, call depth first search with E as an initial state, and if success is returned, signal success, otherwise continue in this loop only. So this is a reference towards the depth first search here. And after that, other than that, I will discuss the advantages and the disadvantages of depth first search as well. So for the depth first search, we have an advantages. There are two advantages and as well as the two disadvantages as same. So the first advantages, we have depth first search requires very less memory, as it only needs to store a stack of nodes on the path from the root node to the current node. And the second advantages is it takes less time to reach to the goal node. And the disadvantages we have here is that is in the same case, that there is a possibility that many states keeps reoccurring and there is no guarantee of finding the solution. And the depth first search algorithm goes for the deep down searching, and sometimes it may go into the infinite loop as well. With the same regard here, now here we'll discuss a question here, that is prove that breadth first search is a special case of uniform cost search. This has also been asked for 5 marks. So it can be proved that in the case where all the step costs are equal, it means their value must be equals to 1 or any other constant. For that, we can say here that is your f of n equals to g of n, and where that is equals to 1 multiply depth of n. So here that g of n is a multiple of the depth of n, and the breadth, that is your breadth first search, is a special case of uniform cost search here. Now we'll discuss about the difference between breadth first search and the depth first search, because we had gone through with them deep, and now we are cleared about the concept of breadth first search and the depth first search. So for that sake, we'll discuss about difference between breadth first search and depth first search. So here almost we'll discuss the four differences between the breadth first search and the depth first search here. In the terms of the breadth first search and the depth first search, the first differences we have is in the BFS uses the queue data structure for finding the shortest path, and for the depth first search, the DFS uses the stack data for finding the shortest path. For the breadth first search, the BFS is most suitable for searching vertices of which are closer to the given source, and the depth first search is most suitable when there are the solution away from the source here. For the breadth first search that considered the all neighbors first and therefore not suitable for decision making tree used in the games or puzzles here. For the depth first search is most suitable for the game or the puzzle problem here. In the same case, we can say that here that in the breadth first search differences between the BFS and the DFS, where that the time complexity of the BFS is 0, and that is O V plus E, and where V stands for the vertices and E stands for the edges. And for the time complexity of the DFS here, that is your O and V plus E, where the time complexity of DFS is this, where in the same case V stands for vertices and E stands for edges here as well. Now we'll discuss about the production system. In the case of the production system, that they had asked you about what is production system, explain the various types of production system. First we'll go ahead with the production system, then we'll discuss the types of production system here. Production system, that's the search forms the core of the most intelligent processes. Hence the AI programs are structured in such a way that describing and performing the search process becomes easy, and the production system provides such structure. A production system consists of a set of rules, each consisting of a left side that determines an applicability and of the rule, and the right side that describes the operation to be performed if the rule is applied, and one or more knowledge databases that contain whatever the information is appropriate for the particular task, a control strategy that specifies the order in which the rules will be compared to the database, and a way of resolving the conflicts that arises when the several rules match at once, and a rule applier here as same. For that the production system here. In the same case, if I'm talking about with the reference towards it, that there are the types of production here. So here we'll discuss related to that the types of production system. In the types of production system, we have 4 types of production system. The first we have is your, that is monotonic production system. In the monotonic production system, it is a production system in which the application of the rule never prevents the later application of the another rule, and that could also have been applied at the time and the first rule was selected. The second we have is your non-monotonic production system. Non-monotonic production system here, it is one in which the application of the rule prevents the later application of the another rule, and that could also have been applied at the time and the first rule was selected here. The third we have is your, that is partially commutative production system. Partially commutative production system. Partially commutative production system here, that it is the production a system with the property that if the application of a particular sequence of rules transforms state X into state Y, then any permutations of those rules that is allowable also transform state X into state Y as well. The fourth we have to discuss is your, that is commutative production system. In the commutative production system, it is the production system that is both monotonic and partially commutative. And these were the types of production system. The first is monotonic production system, non-monotonic production system, partially commutative production system, and commutative production system here. Now we'll go ahead and detail that we'll go discuss what were the various production system characteristics and define the various issues involved in the design of the search program. So that will discuss the issues and as well as the characteristics in the detail. So here we'll discuss about it various production system characteristics. So in the various production system characteristics here, the first characteristics we have is that is simplicity. In the simplicity, that the structure of each sentences in a production system is unique and uniform as they use if-then structure. These structures provide the simplicity is in knowledge representation, and this feature of the production system improves the reliability of the production rule as well. For that same case, the another one we have is your modularity. In the modularity here, this means that the production rule code that the knowledge available in the discrete pieces as well, and the information that can be treated as a collection of independent fact which may be added or deleted from the system with essentials and no deleterious side effects as well. The third is that is modifiability. Modifiability here, that this means the facility of modifying rules, and it allows the development of production rules in the skeletal forms, and that first and then it is accurate to suit a specific application as well. Now we'll discuss the fourth one, that is knowledge intensive. In the knowledge intensive here, the knowledge base of the production system stores pure knowledge, and with this that this part does not contain any type of control or programming information. Each production rule is normally written as an English sentence, and the problem of the semantics is solved by the structure of the representative as well. Now we'll discuss about the issues involved in the design of the search programming. Issues involved in the design of search programs. For this, the first issue that we face is that the direction in which the conduct of the search, forward or backward tracing, where that the tree that can be searched that forward from the initial node to the goal state, or a backward from the goal state to the initial state. The second is that how to select the applicable rules, that is your matching. In the same case, to select the applicable rules, it is crucial, it is critical to have an efficient procedure for making matching rules against the states as well. The third, we have how to represent each node in the search process. This is the knowledge representations problem, or the frame problem. For problems like chess, a node that can be fully represented by a simple array, and in more complex problem solving, however, it is impossible to represent all the facts as well. Now we'll go ahead with the detail that what we have to discuss is heuristic function. In the heuristic function, they had asked you about that what is the heuristic function, differentiate between a blind search and the heuristic search, that we'll discuss in the detail, and what is the heuristic search, give the desirable properties of the heuristic search algorithm. So first we understood about the heuristic search, then we'll go ahead further. In the heuristic search, a heuristic function is a function that ranks alternative in a search algorithm at each branching step based on available information to decide which branch to follow, and in the same case where that it takes the current state of agent as its input and produces the estimate of how close agent is from the goal. And the heuristic method might not always give the best solution, but it guarantees to find a good solution in a reasonable time. Heuristic function estimate how close a state is to the goal, and that it can calculate the cost of the optimal path between the pair of the states, and the value of the heuristic function is always positive here. Now we'll discuss about the properties of heuristic search. Properties of heuristic search. So in the properties of heuristic search here, that the first property we have is here, that is admissibility condition. In the admissibility condition here, the algorithm A is an admissible if it is generated to return as optimal solution here. With the same case, the second we have is your completeness condition. In the completeness condition, if I'm talking about that, the algorithm A is a complete if it always dominates with a solution. The third we have is your dominance property. In the dominance property, let A1 and A2 be an admissible algorithm with a heuristic estimation function, that is H1 and H2 respectively. So A1 is said to be more informed than A2, where H1 of n and H2 of n for all n here, that A1 is said to be dominate A2 here. In this, that is dominance property. So the fourth we have, and the last as well, that is optimality property. In the optimality property, the algorithm A is an optimal over a class of algorithm, and if A that dominates all members of the class. So this is what the properties of heuristic search we have: the admissibility conditions, completeness condition, dominance property, and optimality property as well. Now we'll discuss about the difference between the blind search strategies and the heuristic search strategies in a detail. Difference between blind search strategies and heuristic search strategies. So in this we can explain at least more than the five differences between both. So here in the first blind search strategies here, the first difference is that the blind search technique has an access only to the problem definition, and for the heuristic search strategies that has an access to the heuristic function. differences here, that is difference between the blind search strategies as I told you about it, and the heuristic search, where the heuristic search technique has access to the heuristic function as well as a problem definition. The second differences of a blind search we have is the blind search is less efficient and heuristic search is more efficient. The third is that every action is equally good in blind search, and where every action is not equally good in heuristic search. The fourth difference, that the many problems are not solved by the blind search, but here most of the problems are solved by the heuristic search. The fifth difference, blind search is known as the uninformed search, and heuristic search is also known as informed search here. And that is, blind search uses more computations and heuristic search use less computation here. And in the same regard of it, that the blind search techniques include breadth first, depth first search, and heuristic search technique includes best first, and of course the abstract, etc. So these were the 7 differences between a blind search strategies and heuristic search strategies here. Now we'll discuss why heuristic search is better than the blind search. That is very important, and even though that has been asked of 5 marks as well. Why heuristic search is better than the blind search. So here the algorithm and the strategies for the exhaustive search are sometimes called the blind search method because they lack the power of knowledge guided search, and a blind search method do not need knowledge. They take that is O of h b ki power d time and od space here, and in order to solve the problem efficiently it is often necessary to construct a control structure that is no longer guaranteed to find the best answer, but will almost that always find a very good answer, and this is a heuristic search method, where the heuristic search guarantees to find a good solution in a reasonable time. By sacrificing the completeness, it increases the efficiency, and it is useful in solving such problem which could not be solved by any other way as well, and hence the heuristic search is better than the blind search, and because it makes the use of the domain knowledge as well. So this is why heuristic search is better than blind search here. Just about it, that is explain about the hill that is climbing algorithm, and same for that with the drawbacks of how it can be overcome and the problems of hill climbing algorithm as well. So we'll discuss here, that is your hill climbing algorithm. So in the hill climbing algorithm, the hill climbing search algorithm is a simply a loop that continually moves in the direction of increasing values, that is uphill the goal, and it terminates when it reaches a peak where no neighbor has a higher value, and the algorithm does not maintain a search tree, so that the current node data structure only records the state and its objective function value as well. With the same case, the Hell's climbing algorithm states that to evaluate the initial state, if it is also a goal state, then return it and quit, and otherwise, in the same case, that otherwise continues with the initial state as the current state. That loop until a solution is found, or until there is no new operation left to be applied in the current state. So you have to select an operator that has not yet been applied here. In the same case for this that apply to the current state and apply to produce the new state as well. In the same where the evaluate the new state, and if it is the goal state, then return it and quit, and of course if it is not a goal state but it is better than the current state, we'll go ahead with this references, and that is in the same case, but it is better than the current state, and then make the current state as well, and if it is not better than that the current state, then they continue to the loop as well. Now we'll go ahead with the drawbacks of hill climbing algorithm. Drawbacks of hill climbing algorithm. In the hill climbing algorithm, the drawbacks of hill climbing algorithm here, there are three drawbacks, and that is the first drawback we have, that is your local maxima. In the local maxima, a local maxima is a peak that is higher than each of the neighboring state but lower than the global maximum, and hill climbing algorithm that reaches the vicinity of the local maximum will be drawn upwards toward the peak, but will then be stuck with nowhere else to go as well. So the second drawback we have is here, that is plateau. In the plateau is a flat area of the search space in which the whole set of neighboring state has become the same value, and a hill climbing search might be unable to find it way off to the plateau. The third we have is here, that is ridges. In the ridges here, ridges result in the sequence of the local maxima that is very difficult for that greedy algorithm to navigate. Now we'll discuss to overcome the drawbacks of hill climbing algorithm. Overcome the drawbacks of hill climbing algorithm. So to overcome that is the drawbacks of hill climbing algorithm, there are three, and that is the local maxima and a plateau and of course the ridges. That were the drawbacks we have to overcome with that, with a definite way. That is, the first is the local maxima. In the local maxima here, that the backtrack to some earlier node and try going in the different directions, and to implement this strategy, maintain a list of the path almost taken and go back to one of them if the path that was taken leads to the dead end as well. And in the same case, the second we have your plateau. In the plateau here, that make a big jump in the some direction to try to get a new sections of the search space, and if the only rules available describe single small steps, apply them several times in the same direction. And the third we have is your ridges. In the ridges here, that is, apply two or more rules before doing the test, and this corresponds to moving in several directions at once as well. Now we'll discuss, write a short note on the heuristic research that we had done, and what are the heuristic search techniques of AI, and I explain in the detail. So in the reference towards it of hill climbing, where we had discussed about it, and heuristic search techniques. Heuristic search technique. In the heuristic search technique, there are 7 search techniques here. The first we have is your generate and test. The second we have hill climbing algorithm. The third we have is your best first search. The fourth we have problem reduction, that is AO abstract search. The fifth we have, that is your A abstract algorithm. The sixth we have is your breadth first search, and the seventh we have as your depth first search. And here we had discussed about the hill climbing algorithm in a detail, so that you can answer of 5 marks in 16 and 17 that has been asked here. Let's go ahead with another one, that is to discuss the problem of water jug with heuristic search technique. And for that we have to use the production rule, where we will discuss the whole in reference towards it. And with that same case here, Now we'll discuss related to the water jug problem. So in the water jug problem here, that is has been asked of 10 marks in 15-16. So in the water jug problem, you are given two jugs, a 4 liter and a 3 liter one, and neither has any measuring marker on it, and there is a pump that can be used to fill the jugs with water. And how can you get exactly 2 liters of water into the 4 liter jug? And the state space for this problem that can be represented by the ordered pairs of integers x comma y, such that x equals to 0, that represents the quantity of water in the 3 liters jug. The start state is 0 comma 0 and the goal state is 2 comma n for any value of n here. And for that, if you are dealing with the same case, you have to fill it. So with that same references, when x comma y is tends to 4 comma y, and where if x is less than 4, so then fill 4 liter jug. And when x comma y, that is x comma 3, and then after that we will go ahead with this. If x is greater than 0, then of course pour some water out of the 4 liter jug here. Let's go ahead with this here in the same references here, that is your the production rule. Will deal with it. That is in the production rule, x comma y is 4 comma y, and if x is less than 4, then you have to fill 4 liter jug. And if that is x comma y gives x comma 3, and if y is less than 3, fill 3 liters jug. And if x comma y tends to x minus t comma y, then if x is greater than 0, then pour some water out of the 4 liter jug. If x comma y gives x comma y minus t, then if y is greater than 0, so here pour some water out of the 3 liter jug. The next is x comma y gives 0 comma y here, and that is if x is greater than 0, so empty the 4 liter jug on the ground here. And if x comma y gives x comma 0, if y is greater than 0, then empty the full 3 liter jug on the ground. And another one is x comma y gives 4 comma y minus 4 comma minus x. Then if x minus y is greater equals to 0 and y is greater than 0, y is greater than 0 as well. So in the same case, pour water from 3 liter jug into the 4 liter jug until the 4 liter jug is full. Then x comma y gives x minus 3 minus y 3, that and if x plus y is greater equals to 3 and x is greater than 0, then pour water from the 4 liter jug into the 3 liter jug until the 3 liter jug is full, and that is x comma y gives x minus y comma 0. If x plus y is less than equals to 4 and y is greater than 0, so pour all the water into the 4 liter jug. X comma y 0 comma x plus y as well. If x plus y is less than equals to 3, then x is greater than 0. Here pour all the water from the 4 liter jug into the 3 liter jug as well. And in the same case here, that is your 0 comma 2 comma 0, then pour the 2 liter from the 3 liter jug into the 4 liter jug here. And the 12th step is, that is 2 comma y gives 0 comma y. Then of course empty the 2 liter in a 4 liter jug on the ground. This is how the this has been used in reference towards it. Now we'll discuss what is the problem space and how problem can be defined as a state space search. In the same case, we have problem space. In the problem space here, the problem space refers to the entire range of the component that exists the process of finding a solution to a problem, and this range starts with the defining the problem and then proceeds with the intermediate stage of identifying and testing the possible solution, and ends with the final stage of choosing the implementation of situation as well. In the same case, talking about this, that the problem is the question which is to be solved, and for solving the problem it needs to be precisely defined, which means defining the start state, goal state, and other valid state and transitions. A state space representation also for the formal definition of a problem, which makes the movement from the initial state to the goal state that quite easily as well. For example, the 8-tile puzzle consists of a 3 by 3, that is 3 absolute 3 square frame board, which holds that S movable tiles numbered 1 to 8, and one square is empty, allowing of the tile movement, and with this real allowing the adjacent tiles to be shifted. And the objectives of the puzzle is to find a sequence of tile movement that leads from the starting configuration to the goal configuration as well. In the same case, if I'm talking about here with the same case, that is we having 3, 8, 1, 6 to 5, and here it is 1 empty, and this is your 4 and 7 to be transformed into, that is your 1, 2, 3, 8, 4, this is empty space, 7, 6, and 5. The states of the 8 tiles puzzles are different permutations and of the tile within the frame here. And now we'll discuss about the standard formulation of the problem, where the standard formulation of the problem that was discussed here in the detail as well. We are in the same case we'll discuss about the standard formulation of the problem. In the same case, the first is your states, initials, and goal, and with the reference towards it, states, initial, and goal. That is state, it specifies the location of each of the 8 tiles and bank in of the nice sequence as well, squares. And in the initial state, any state that can be designated designed as an initial state, and the goal is many goals configurations are possible, and the legal moves are the state, they generate the legal state that results to trying the 4 action. The first is your blank moves left, or blank moves right, a blank moves up, and blank moves down. So the path cost is each step costs 1, and so that the path cost is the number of the step in the path here. Now they had asked you about that proof that the breadth first search and the depth first search are the special cases of the best first search, that is of 10 marks. So yes, best first search is a combination of depth first search and a breadth first search here. The depth first search is a good because the solution that can be found without computing all the nodes, and the breadth first is good because it it does not get trapped in a dead ends as well. And the best first search allow us to switch between the path, thus gaining the benefits of the both approaches, and at each step the most promising node is chosen. And if one of the nodes chosen generates nodes that are less promising, and it is possible to choose another at the same level, and in effect the search changes from the depth to breadth as well. And if on analysis there is no better, then the search method reverts to the descendants of the first choice and proceeds the backtracking as it were. Now I'll talk about the adversarial search here. Adversarial search, in the reference towards it, that the adversarial search is a search where we examine the problem which arises when we try to plan ahead of the world and the other agents are planning against us. And the environment with more than one agent is termed as multi-agent environment, in which each agent is opponent of the other, and we all play that they are playing against each other, and each agent next needs to consider the action of the other agent and effects of that action of their performances. So the searches in which two or more players will with conflicting goals are trying to explore the same search space for the solution and are called adversarial searches, often known as games as well. So here the another question that can arise is how branch and bound technique could be used to find out the shortest path solution for the traveling salesman's problem. And branch and bound search, that is very important, and for that references we have to talk about it. And for the lower bound and the TSP, and of course that the complete graph for the 5 vertices, we have to discuss about that as well. So in the branch and bound we will discuss this in the detail in the next coming class. And the things the short things that we'll discuss here and in the reference towards it, if I'm talking about. So with these we'll discuss the short answers first that is possible here. So now we'll discuss that why game playing is good for candidate of AI. Explain. Has been asked in 14, 15 or 5 marks. So the playing games in a computer in one of the major goals of the researchers in the computer science, and the first chess program was written by the Claude Shannon and by Alan Turing, and the checkers and considered as a landmark in the area of the computer game playing as well. The reason why the game plays are the pivotal role of in AI, and that the rules of the games are limited, hence extensive domain specific research is not needed, and the development of the program is easy as many people have expertise in that. And game provides structured task wherein success or failure that can measured with least effort, and the game's picture real life situation in a constant fashion. So these were, you can write it down when you are gone through with that this answer, that why is game playing is good for candidate of AI here. In the reference towards it, now we'll discuss that prepare a note that describing the role of the machine intelligence in the game playing. So machine intelligence in game playing. So in the machine intelligence in game playing, if reference towards it, so here that the game playing involves the task in the memory, mathematics, and reading and even music. And in AI, the abstract nature of the games makes them an interpreting interesting subjects for study. That machine intelligence plays a vital role in a game playing, where machine intelligence can be used to make a particular game for the following reason. The first, we have the state of a game is easy to represent. The rules of the games are limited and precise, and hence the domain specific knowledge required in a quite less, and they provide a structured task, therefore the success or the failure that can easily be measured, and so consider all the state and the rules of the particular game machine intelligence that can be applied to that game for describing all the possible moves as well. And we have to search all the possible moves, and these are generally done by the generate and the test procedures, in which the testing is done after varying amounts of work by the generator as well. In the same case, at one extreme, the generator generates the entire proposed solution, which the tester then evaluate, and at the other extreme, the generator generates individual moves in the search space, and each of which is then evaluated by the tester, and most promising one is chosen. Machine intelligence uses the search-based problem that solving program to improve the effectiveness. This can be done. The first is that to improve generate procedures so that only the good moves are generated, and improve the test procedures so that the best moves will be recognized and explored first as well. In the same case, there are many important questions that has been asked in that we had even though discussed about it, and that there are many that we have to discuss further as well, because these were the important topics. And in that same case, the alpha beta pruning, and then of course for the reference towards the game tree, that is also an important one. So now we'll discuss an OR graph and an OR graph here. OR graph and and OR graph. So here that OR graph and an OR graph here. In the reference towards it, we'll discuss first OR graph, then we'll discuss and OR graph here. In the OR graph, that OR graph is the simplest kind of a graph, and in this graph, for from each node, there emerges a set of arcs, one of which is alternate moves that can be made from the state representing the originating nodes, and the nodes pointed to by those arcs is known as the successors of originating nodes as well. And to find a solution to a problem, a search procedure must find a path through the graph, and starting from the initial node, from that it will search until it find out the solution. The AND/OR graph here, the AND/OR graph is useful to representing the solution of the problem that can be solved by decomposing them into the set of the smaller problem, and all of which must then be solved. And this decomposition generates the arcs that we call AND arcs, and one AND arcs may point to any number of the successor node, and all of which must be solved in order for the arc to point a solution. In OR graph, the several arcs may emerge from a single node, and indicating a variety of the ways in which the original problem might be solved, and that is why the structure is called AND OR graph here. In the same reference towards it, we have to discuss about the max constants, and even though we have to discuss about the CSP problem as well, and that is in the contrast, that is in the detail as well. Now we'll discuss about it, that is your AO algorithm in deep. AO abstract algorithm. In the AO abstract algorithm, that A modified version is a abstract algorithm is used for the AND OR graphs, and A abstract algorithm is not an adequate for AND or OR a tree, because for our AND a tree, all branches of it must be seamed to arrive at a solution. The AO algorithm here, in the reference towards it, that the place the start nodes as on an open, and using the search tree constructed thus far, compute the most promising solution. Select a node n that is both an open and a part of T naught, and remove n from one's open and place it on closed as well. And if n is a terminal goal node, and that label n as solved if the solution of n results here in any of an n's ancestors being solved, label all the ancestors as solved, and if the start node s is solved, then exit with the success where the T naught is the solution tree. Remove from open all nodes with a solved ancestor, and if n is not a solvable node operator that cannot be applied, label and as unsolvable. If the state node is labeled as unsolvable, exit with failure. And if any of the n's ancestors become the unsolvable because n is, so label them unsolvable as well, and remove from open all the nodes with the unsolvable ancestors. Otherwise, expand node n, generating all its successor for each such successor nodes that contains more than the one subproblem that generate their successor, to give the individual subproblem as well. To attach to each newly generated node a back pointer to its the precedent, and that compute the cost estimate that is of H abstract for each newly generated node and place all such nodes that do not yet have a descendants and open, and next recompute the vision of h abstract and n and each ancestors of n as well. Now we'll discuss about bean search algorithm. In the bean search algorithm here, this is an attractive heuristic search technique because it permits the searching to be done on the multiprocessor machine and therefore reducing the computedness as well, and that is your computations as well, and reduction in the computation is achieved by purging some paths and selecting only selected paths as well. And the searching process is similar to the breadth first search, wherein the searching protocol level by level, and at each level heuristic functions are applied to reduce the number of paths to be explored, and it is done to keep the width of the beam to be minimal. The width of the beam is fixed, and whatever be the depth of the tree, the number of the trees, the number of the alternatives to be scanned, and the product of the width and the depth as well. In the same case, if we are talking about the algorithm here, in the same, the first is that let the width of the beam is w, and then put the initial node on the list start, and if the start is empty or start is equals to goal, then terminate search and remove the first node from the start and call the node A, and if A equals to goal, then terminate search with success. Else, if nodes have successors, generate all of them and add them at the last start, and use the heuristic function to rank and sort all the elements of the start. Determine the nodes to be expanded, and then the number of the nodes should not be greater than w. Name these as a start 1 and replace start with start 1 and go to the step 2 here. That we had done, put the initial node as the list start here. Next, after that, other than that, the second thing we have to discuss is your constant satisfaction algorithm. Constant satisfaction algorithm. The constant satisfaction algorithm here, that in a real world where we work have lots of constant, even in the solutions are found without violating any the constant, that to solve the problem in the areas human beings use extensive domain specific and heuristic knowledge. Heuristics are used that not to estimate the distance to the goal but decide which node is to be expanded next. For example, the design problems in manufacturing and the movement of semi-finished that goods in assembly lines, planning an optional travel tour covering major tourist spots with the minimal expenses of the resource, etc. And the cryptarithmetic problems are typical constant satisfaction problem. The general forms of the constant satisfaction procedure is: the first is to select an unexpected node of the search graph. The second is to generate all the possible new constants, apply the constant inferences rule in the selected nodes. The third is if the selector set of the constant contain a contradiction, then report that this is the path and path is a dead end. To report the success if the set of the constant contradictions describe the complete solution, and if neither of the contradiction nor the complete solution has found, then apply the problem space rules to generate a new partial solution that be the constant with the current set of constant, and insert these partial solution in the search graph as well. In the same case, if I'm talking about with the reference towards it, that is that we had discussed about it, about the bean search algorithm, and of course for the AO algorithm and the constant satisfaction algorithm as well. In the same case, if I'm talking about more detail about the AI, there are many more topics to be discussed, and that is your completeness, and these are the A abstract search as well, and that is we had discussed about the AO abstract search, and now we'll have to discuss the A abstract algorithm as well. That we'll discuss in the next coming class. And but for the best first search, if I'm talking about that is in detail, so in the reference towards it, the best first search, it is a combination of the depth first search and a breadth first search. As I told you, depth first search is a good because a solution that can be found without decomputing all the nodes, and the breadth first search is good because it does not that it does not get trapped into the dead ends. And the best first search allows us to switch between the paths, thus gaining the benefits of the both approaches at the end of the step of the most promising node has been chosen here. and that if one of the node chosen generate nodes that are less promising, it is possible to choose the another at the same level. In effect of the search changes the depth to breadth here. And if if an analysis there is no better than that, this previously unexpected node and branch is not forgotten, and such method reverts to the descendants of the first choice and proceeds backtracking as it were. In the hill climbing, one of the most is chosen that the other rejected, and the others are never reconsidered, while in the best first they are safe to the enabled to revisit if an impasse occurs on the apparent best path, and also the best available state is the selected in a best first. Even its value is the worse than that, the value of the node just explode, whereas in the hill climbing the progress stops if there are no better successor nodes. And the best first search algorithm will involve an OR graph which avoids the problem of node duplication and assume that each node has a parent link to get the best node from which it came and link to all its successor. And the way if a better node is found, this path can be programmed and that is propagated down to the successor. And this method of using OR graph required two lists of nodes here, and in the same case with the reference towards it, that the open is a priority a queue of the nodes, and that has been evaluated by the heuristic function but which has not yet been expanded into the successor. And the most promising nodes are to the front, that is your closed are the nodes that have already been generated, and these nodes must be stored because of the graph is being used in the references to a tree. And heuristic, in order to find the most promising node, a heuristic function is needed called f, and where f minus or f stick is an appropriation of fa, where that is that is made up to the parts of g and h, and where g is the cost of the going from the initial state of the code current node, and g is considered to the simply the context of the number of the arcs that is traveling the initial cost of the getting from the current node to the goal state as well. The functions is the appropriate value of the estimate that getting from the initial state to the goal state, and both g and h is a positive value of the variable that we had discussed about it. In the next class we'll start with the branch and bound search here, and so for this class we will be end up with here only. And first of all, it's a huge request from our side to all of you, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And here in this class what we had covered up in the first unit, and we had covered up to introduction to AI, and now we had started with introduction to search. So introduction to AI, we had covered up introduction to AI, and foundations and history of the AI, that application of AI, intelligence agent, structure of intelligent agent, computer vision, neutral language processing, that we had done. Introduction to search, this is the second unit, and here we had started with your that is introduction to search, that is searching for the solution, uninformed search strategies, informed search strategies, local search algorithm and optimistic problem, adversarial search, and search for the games we had done. Alpha beta pruning, we have to start with that. And then after that, other than that, we'll complete with the start with the unit third, that is your knowledge representation and the reasoning. Knowledge representation and reasoning, that the propositional logic and the theory of the first order logic. Inferences is the first order logic here, that a forward and a backward chaining, resolution, probabilistic reasoning, utility theory, hidden Markov models, that is HHM, Bayesian network as well. In unit 4 we have to cover up the machine learning, supervised and unsupervised learning, decision tree, statistical learning models, learning with the complete data, naive Bayes model, learning with the hidden data, AM algorithm, and reinforcement learning as well. In the unit 5th, we have to cover up the pattern recognition, that is the pattern recognition, introduction to design principles of pattern recognition system, statistical pattern recognition, parameter estimation method, principal components analysis, and the linear discriminants analysis, that is the classification technique, nearest neighbor rule, Bayes classifiers, support vector machine, SVM, and K, that is the means clustering here. So that's all here. First of all, it's a huge request towards to all of you, please go through with the subscribe button, please like, share and subscribe our channel because your support is important to us. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give us suggestion on a comment box. Thank you.